So for either anybody who is absent, it was last Friday, we kind of snuck in a day here of discovering some things. So I just want to kind of review with you some things that we discovered and you kind of took some notes on. So we talked about parabolas. Excuse me. And we talked about how these shifts take place. So you are just following along with me right now. So I really need you listening to me. Lots to talk about. So we talked about if it's y equals x squared. So Joey, I'd rather have you watch up here, sweetie. So y equals x squared, we can do 4 different things to it. First thing we talked about was, okay, let's take y equals x squared and make it plus 3. And we saw what that did. That we graphed our parent function that's called, so that's your y equals x, and you're always comparing it to that. And then it took the y equals x, and it went exactly what you thought it was going to do and made it a plus 3, okay? So let's just kind of really quickly review where this shape comes from. So do you remember that if this is your x and this is your y, and this is your y equals x squared, anytime you want to graph something, you just make a table of values. If you take x, 0 squared is 0, 1 squared is 2, 2 squared is 4, 3 squared is 9. And you've seen these numbers before, haven't you? These are those perfect square numbers that we've been dealing with during all those crazy factoring special products, right? So take 2 and square it and you get 4. These are the points that when I plot them, create that shape right there. That's our parent function. So then what happens when I make these negative values? Negative 1, negative 2. Well, what's negative 1 squared? Positive 1. Negative 2 is still positive 4. Negative 3 is positive 9. Thank you. So all of these values will always be positive, right? Okay? So we work through that, and that's what creates that shape there. So then basically by taking this and doing a plus 3, which is the red shape that you're looking at, all I'm doing is adding 3 to these x coordinates, or these y's. So instead of 1, 2, it would be 1, 5, which is 1, 5. And then this would be 2, 7, and 3, 12, and so on, right? So that's why it shifts it up 3. So we learned about the x, and the adding 3 to it is called a vertical shift. So do you remember that? Okay. Then we talked about what to do when, this was an easy one, if I took the y equals x squared and made it negative, and then hit graph. We took our parent function and it just, we don't want to, our first instinct is to say flipped, because that's really what it does, but we want to use the right terminology, and a flip in math is really called a reflection. Good. And it reflects over which axis? The x-axis. And if you can't picture that, I want you to just picture taking that and folding it over, and if it folds over on the x-axis and these lines fall on these lines, that's what a reflection is. Yeah.
Why does it circle?
Because when we did these here, because you weren't here for this. When we create this table of values, these values dictate what our shape is going to be. So if I have 1, 2 versus 0, 0, 1, 1, 2, 4, 3, 9, that's where the shape originates from. So, and then to get these over here, we had negative 1, 1, negative 2, 4, negative 3, positive 9. So we found out that these shapes we're talking about are symmetrical figures. So if I were to take this piece of paper literally and fold it on that x-axis, this line it's not going to because mine is hand-drawn, it should fall exactly on the other one. Okay, so that's where the U shape comes from. Okay, good question. So now, we've learned 2 things about these quadratics, that it can shift up or down, and it can reflect. Now, the other thing we learned about was putting a number in front of that. So let's take y equals 3x squared. This is the one of the 4 that I am the least concerned about. It's not really an Algebra 1 topic. It's an Algebra 2 thing you guys are going to work more with. I just figured I may as well show you it when I was showing you all the other 3. So here's the thing I asked you, what do you think you could do to the shape? You can turn it upside down. You could change the width of it. You could make it really skinny and narrow, or you could make it really big and stretched out. And you can move it left and right. So this, if you remember, changed the size of it. And it didn't change it how you thought it was going to change it, did you? So there's your parent function with your coefficient of 1. And here's your coefficient of 3. It made it narrower. And you thought that 3 is bigger than 1, so it must be getting wider, but it didn't. So this is called a compression, right? So kind of like you're pushing it together like that. So then what makes it go out wide? A number that is in between 0 and 1. So any type of proper fraction is going to widen it, and that's called a stretch. Okay? So you need to know stretch versus compression, which number does which, okay? So going back to that did the opposite of what you thought. And then the other one we talked about was what happens when you put a number in the parentheses and then square it, okay? So we're taking the x plus 5, or the x minus 5, and then squaring it. So the only thing we haven't seen this shape do yet is shift side to side. So this also did the opposite of what you thought it would do. You looked at that negative 5, and you thought that it was a negative 5, and you thought it's going to shift to the left. And then in a minute, I'm going to ask somebody to explain to me why it shifts to the right instead of the left. I explained it last Friday. So Megan, I need you to put the book away, please, and pay attention. So why does that shift to the right? Okay, yep. What concept, what mathematical concept? What does that have to do with? Yes. Yes, when you're finding the 0 of the function, if this parenthesis equals 0, x would have to be positive 5. So yeah, you're looking at the opposite of what it is. So that shifts that way, okay? All right, so when I put all of these together, say negative 1/4 x plus 2 squared minus 7. It's all 4 changes in 1. So I want you to look at this as that negative says it's going to reflect, and open downward will say. That 1/4 means that it's going to stretch. That plus 2 means that it's going to shift 2 to the left, yeah? But that minus 7 does what it says it's going to do, and it's going to shift 7 down. So my question to you is, which quadrant will this vertex be in? Which quadrant? If it's shifting 2 to the left and 7 down, Jasper, 3, right? So when I graph this, again, we wait for our parent function to show, because everything is compared to that. And then it's going to shift 2 to the left and 7 down, and there's your vertex, and it's opening down. Okay? So that's kind of that. So now what I want to talk about next is this point right there, and that has to do with the vertex. So let's take a look at this equation, and now it's time for you to go ahead and get something to write out, and we're going to talk about vertex form. Oh, did you get a chance to write? Did you write this on your paper? Okay. If you didn't get a chance to write this, I want you to write the words vertex form somewhere on your paper. If you write it in this box right here, you know that there won't be anything else in there. So, okay. While you're writing that, y equals a times. Well, let's get the black marker out. Whoops, I don't want to do that. What's that?
Is that what we're doing these?
Yep. This is the form that we've been working with, and I'm going to show you, we're going to write it in a minute here. Now, do you remember back to slope-intercept form? Do you remember why they called slope-intercept form slope-intercept form? Y equals 3x minus 2? Because just from looking at it, you can tell the slope and the intercept. That's why they call it slope-intercept, right? The slope is 3, the y-intercept is negative 2. So why do you think they call this vertex form? Because just from looking at it, without doing any rearranging or calculating, you can find the vertex of this parabola. And that's your main learning target for today. If you can find the vertex of every parabola I give you in vertex form, you're good. It's really easy. So, A, we know, controls the width. The H, be careful. I want you to think about what shift does this control that begins with H. The left or right, what's another way? Horizontal. So I want you to consider this your horizontal shift. And then your K, the only thing I can think of that kind of helps you think of stuff is a kite. Yeah, climb. So where does a kite go? It goes up in the air and then it comes back down. So K is going to control your vertical movement, and the H is going to control your horizontal movement. Those are really the two things you need. The vertex can be found from taking the H value and the K value.
Wait, what's that? Is that an X or a Y?
That's a V. Yeah. V for vertex. Now, so when you see V equals H comma K, I'm going to explain what that means right now. And that's really, really important for understanding vertex form. Okay? So, on a separate sheet of paper now, we are moving on to some notes. I'm going to rewrite this. And I'm going to rewrite this like that. That I'm putting in dark black because that will be almost in every problem you see. It's going to be the H and the K that you see change and are replaceable. The rest of these things stay, okay? So you're really just putting in different numbers. So when I have a y equals x minus, and then we're going to say we're going to make this a minus 3 plus 5. Okay? I'm going to ask you to do 3 things with this. I want the vertex. I want the axis of symmetry, which we're going to talk about in a minute. And then I'm going to ask you to sketch this. Okay? And I need you to understand what sketch means. Sketch is different than graph. Literally on the paper that they give you, they're going to say sketch it. A sketch is kind of an approximation, isn't it? A graph means you better get those points exactly where they're supposed to be. So you're just kind of doing a loose graph today. You're just sketching it. So we're going to talk about this in a minute, so hold off on that. So if the vertex is an ordered pair, you can tell by the H comma K where it's supposed to go. But here's the tricky part. This minus, right now you're looking at that and you think that that's a negative 3. Hopefully the way that I put it in dark magic marker here and that's separate, you know that the minus is part of the formula. That minus does not belong to that 3. I know it's the opposite of everything I've been teaching you about solving equations, right? Okay, so if that minus is part of the formula, that 3 is really a positive 3. And that K, though, is exactly what it appears to be. So this is going to shift 3 to the right and 5 up. So your vertex then, we're going to talk about axis of symmetry in a minute, is going to be in your sketch in quadrant 1. And then from there, you don't need any other points for a sketch. You just have to ask yourself, is it opening upward or downward? Do you see a negative there? Nope. So it's going to open upward. And I don't even see a number there. So you're just going to do a regular width with a coefficient of 1. You don't have to, we'll do it on in a minute where I'll give it a stretch or a compression. Okay? So we're going to come back to that axis of symmetry. Let's do another one. Let's take y equals x. We'll put, I'll do this one in red.
Wait, what's the axis of symmetry?
That we're going to do that. 1 second. Yes, x plus, this one I'm going to make a plus, and we're going to make this a 2, and we'll do this one minus 4, or minus 1. Okay, so on the paper that you get today, you're going to have to explain to me what the vertex is, your axis of symmetry, and you're going to talk about, again, that in a minute, and then your sketch. So let's start with the most important part, and that's finding the vertex. So if you're telling me that that's a plus, I am all about shortcuts, guys, but not unless you understand the reasoning why. Well, you look at that and you see a plus 2. And then you say to yourself, well, Mrs. D just told me the formula is really x minus. And if that's a negative, if that's a plus, that must mean that this plus came from the fact that I'm subtracting a negative 2. So my vertex is going to be negative 2, comma, negative 1, right? So the K is true to what it says it is, but this one, the horizontal, is opposite. Good? So now when I ask you to sketch this, let's make this a negative 5, just for the heck of it there. Find your vertex, the most important part here. So there's your vertex, negative 2, negative 1, right? Now, from there, does it open upward or downward? Because I just threw that negative in there, it's going to open down. And those are the only 2 things I'm checking for. I know you're looking at that. You see that it's a 5. You know that a 5 thinks that it should be wider, but it really makes it narrower, so it's a compression. So if you want to do that and make it a little narrower, then like the regular one would be, you're good. If you don't, like, I'm not going to grade you on it and say, nope, that's not narrow enough. It's a total estimate. It's a sketch. So the only thing I'm grading you on, did you get the vertex in the right spot? And did you open it upward or downward? Those are the 2 things I'm looking for. Okay? We're going to talk about that right now. Okay? So let's talk about axis of symmetry. And to talk about axis of symmetry, I want to take you back to, I don't know, 3rd grade, 2nd grade even. You're given a bunch of shapes, and your math teacher asks you to draw the axis of symmetry, right? Or which figures are symmetrical. So if I said to you, an axis of symmetry, do you remember? It's like a dotted line usually. And if you fold it on that dotted line, this part would fall exactly onto the other part. Okay? So this is an axis of symmetry. A square has an axis of symmetry like this. Doesn't it also work this way and this way? An axis of symmetry for a circle, as long as it goes through the center, there's an unlimited amount, right? Okay? Here's an axis of symmetry for this, right? If I fold this, is this an axis of symmetry though? No. Okay, so you get it. So here's the really cool part. Every parabola, by nature and mathematical reasoning, is a symmetrical shape, isn't it? Every parabola I draw, I can take and draw an axis of symmetry through it. And meaning, I will to fold it on that, and this will fall exactly onto the other side. If it doesn't, then it's not a parabola, and it's not using those definitions of it. So, I want you to think about this. On this paper, I'm going to, let's just do this one. Let's do 3, 5. So 3, 5, and we'll just kind of sketch this. Doesn't really matter right now, but. So if the axis of symmetry is this line right here, let's go back to linear. What's the name of that line? Do you remember? Let's do this for a second. If you have a horizontal line like this, the name of this line is y equals -4, doesn't it? Because doesn't every single y value equal -4? 1, -4. 5, -4, right? So then if that's the case, what's the name of this line? Not y equals, but do you remember that? Vertical x. Remember I said v is x, vertical is x equals 1, 2, 3, 4. Here, every single X value is 4. I go 4 to the right, and then 1 up. I go 4 to the right and 2 down. 4 to the right, so that's X equals 4. So, what do you think the axis of symmetry is called here? X equals 3. Why 3? Because the vertex was 3, 5, wasn't it? So if I have a vertex at negative 2, 6, and I go this way and this way, what's the axis of symmetry going to be for this one? X equals negative 2, doesn't it? Isn't the name of that blue line X equals negative 2? So, vertex and axis of symmetry. If you can find your vertex, look, your axis of symmetry is what your X is. But don't just put 2 or negative 2. I need it written as the equation, which is X equals negative 2. Got it? So, vertex and axis of symmetry. Are you ready to do a few more? On your paper, I want you to write y equals x squared minus 4. I want to know the vertex. I want to know the axis of symmetry. And then I want you to sketch it. Okay. Well, something's missing. What's missing? The parentheses, right? So, if you see something that's missing, could you maybe just still do it like this, except if there's no parentheses, that must mean that's that, right? So if you see one that's not like in full out vertex form and you need it to be in vertex form to kind of help you see things, then just do that. So what is my vertex now? 0. Yeah, well, I didn't ask for the axis of symmetry. So my vertex is 0, negative 4, which means I'm not moving left or right. I'm just moving down. Which axis will my vertex be on? The y-axis. I'm not moving horizontally at all. Remember, that's the H. So my axis of symmetry is x equals 0, which is basically the y-axis, right? So when I sketch this, I go to 0, negative 4, and then, okay. You want to see something cool? I know you do. I get so excited about this stuff. I love it. So y equals, you're such a nerd. Let's, for the heck of it, let's factor that. Who remembers what that factors into? Y equals, we just took that test. Okay. Everybody agree with that? Let's find the zeros. The 0 here is, and the 0 here is. Would you remember what I said the zeros were? They were where the parabola touched the x-axis at, right? So do you see how starting out with that y equals x squared minus 4 that you've been factoring for like 3 weeks? This is the version of what it looks like on your paper. Do you understand? Okay? So let's take a look at what this one would be. So what's missing this time? The k, right? There's nothing after the k, which means if k stands for kite and kites go up and down and k is 0, then it's just staying where? On which axis? The x-axis. There is no vertical shifting here. So your vertex is what? Careful. Negative 7, 0. My axis of symmetry is going to be what? X equals negative 7. And my sketch is going to look like this. Negative 7, 0. And that's really all I know. Is it going to go up or down? And one thing you're going to want to make sure is when you're sketching them, make sure that you get that your arrows there. Okay. Are you okay with axis of symmetry and vertex? Yeah.
What's this? How do you find the X?
How do you find the what?
Axis of symmetry.
Oh, you know what? Let's do this one. Because, the axis of symmetry is easy. It's basically whatever your x coordinate is. So if you're saying that x is -7, then that's your axis of symmetry. It's -7. So whatever that x value is, okay? All right. Good on that? So let's do